In this video, we're going to talk a little bit more about forecasting the upper levels of the atmosphere. And forecasting the upper levels of the atmosphere are very important, especially to form a forecasting bias. So when you look at upper level charts, as in 500 millibars, 300 millibars, even 200 millibars, my preference is the 500 millibar chart. You're really just looking at the overall big picture. You're trying to see where your patterns are in the jet stream in order to form a forecaster's bias. So when we talk about the jet stream, we're really talking about the river of wind that flows high aloft in our atmosphere. Roughly about 40,000 feet would be the top of the jet stream, and this is why planes travel that high up, because it is easier for them sometimes to ride in the jet stream. And so when we look at jet stream patterns, especially in the United States, we really look at two types of flows. We look for zonal flows and what is called meridional flows. And what is interesting about meridional flow is that the bigger that those flows are, the more drastic weather patterns that we get. So when we look at the difference between a zonal flow and a meridional flow, a zonal flow is more along the lines of a flat or flatter jet stream, whereas the meridional flow has more waviness to it or more curvature to it. And so when the jet stream is flat, the atmosphere is more or less in equilibrium. And that means there's really no differences or large differences between temperature or moisture. The atmosphere is pretty stable. But when we have meridional flow, that means cold air is advancing in one part of the world, or in our case, the country, and therefore warm air is reacting downstream of the jet stream. So when we look at the differences here, this would be more along the lines of a zonal flow. And so here, yes, there is a little bit of a waviness to it, but right in this section right here, you can see how the jet stream is more or less flat. Yes, you do have a little bit of a trough right back in through here, just east of what looks like to be Italy. And then you see that you have a ridge trough and then a ridge downstream. So that more along the lines would be similar to what a zonal flow looks like. Now, obviously, the flatter the flow, the more zonal it is. But in retrospect, when we look at a meridional flow here, you see that here you have these deep ridges and these deep troughs. So here you have quite large differences in atmospheric temperature and therefore pressure and humidity. And so that would be a meridional flow, and here you would have some pretty drastic weather patterns. So that's the type of patterns that we want to see. We want to really look for where are the troughs and where are the ridges, where the more waviness you have in the jet stream, the more extreme weather you are likely to see. And so when we talk about troughs, we're talking about areas of relatively low pressure, which would feature any kind of precipitation or more unsettled weather. And we're also looking for cooler conditions. And when we look for ridges, it's really just the opposite. We're looking for areas of higher pressure, so more dry weather, sunny days, and we're also looking for warmer weather or hot and humid weather, depending on the type of year. And so there's different maps that will show different aspects of the jet stream. Here would be one at probably 300 millibars, and here you can see that they highlighted the core of the jet stream. And so here would be the area of the fastest winds. And what you usually see on TV, maybe something like AccuWeather, probably put this graphic out. This looks like their work. So here you can see this is pretty much the same idea, where you have a ridge out in the west, and then you have a trough out in the east. And here you can see it's warmer out in the west, colder, and here they mentioned snow showers, but it's more unsettled weather here. And then here would be another example. This would kind of just be the flip-flop. So now we have a trough over the west and more unsettled weather, and then we have ridging out in the east, which would be associated with high pressure and more sunny days. So when we look at this, right, remember that warm air closer to the equator, cold air closer to the poles. When we learn about air masses, we're going to see how air masses, they don't like to stay in the same place. And so what's interesting about air is that it's never satisfied and always wants to move. And you can think about cold air is always willing to move south to warm, and warm air is always willing to move north to cool. So cold air moves south to warm, warm air moves north to cool. And so this is what makes the jet stream wavy. And so when we look at the jet stream as a whole, we talk about long waves versus short waves. So long waves would really be the entire wave, or what is also called Rossby waves, or it's the entire portion of the jet stream. So in the mid-latitudes, we talk about the westerlies. If you go down to the tropics, the long waves there would be the trade winds and so on and so forth. So when we study the atmosphere on a large scale, it's important to note that what happens in one part of the world affects the other part of the world. Take a situation like El Nino. So El Nino, you have the warming of the Pacific waters off the coast of Peru. And so when you have that warming, that means that you have an area of relatively lower pressure. So you have a trough out in that section of the Pacific, which causes ridging out in the east. And so that's why, we look at different parts of the world during strong El Nino or La Nina years. And depending on if, El Nino is at an extreme or La Nina is at an extreme, it affects the weather throughout the entire world. And so that's when we look at the atmosphere at a global scale. But within these long waves, or within the jet stream, are these small little spirals. They're small little circulations, and these are called short waves. And short waves are what are responsible for our weather. So if you've ever been whitewater rafting before, if you can think about a whitewater rafting trip or an example of one, the overall long wave would be the river that you're traveling down, and the short waves are what are created, which would be the actual rapids themselves. So you have the entire river, but then you have the rapids within the river. And so the rapids in our atmosphere were or can be called short waves. And so short waves are responsible for the low pressure systems that spawn our weather. And so when we look at this here, you notice that here would be an example of the westerlies, or here's that long wave circulation around the entire northern hemisphere. And what you notice that here in these dashed lines, they basically have marked off the trough axis. And here you can see that here's a zoomed in portion of the United States. Here they have marked off the trough axis, and what you notice is that towards the right hand side, and we talked about this in another video, on the right hand side, this is where your area of low pressure would be developing, and on the left side, that is where your area of high pressure would be developing. So we're going to go into more detail about short waves in another section of this module, but here would just be a great example of what the jet stream looks like and what troughs and ridges are associated with.